The topic which we are going to discuss here is stack. Objective of this video is to explain the design, use and operation of a stack. Implement a stack using a linked list structure and understand the operation of the stack ADT. So the topics which we are going to discuss here is basic stack operations and stack linked list implementation. First of all, what is stack? Which stores a set of elements in a particular order. Its principle is last in first out. It means the last element inserted is the first one to be removed. What is the first element to pick up? That is the main question. Obviously, the last element inserted is the first one to be removed. For example, stack of coins, stack of books, computer stack, or you can consider the cafeteria. In cafeteria, the plates are arranged in order. So the last place is taken as the first one. So the basic stack operations are push, pop and top. Push, which means insertion, addition, whatever we can see. So push is nothing but inserting a data item onto the stack. That is known as push. Here, so this is the stack initially. After inserting the new value, so inserting the new value which is known as push operation. After inserting the new value, the top is incremented by 1. Next, pop. Pop operation is nothing but deleting an item. So this is the stack. After deleting the data from the stack, the top is decremented by 1. Top is nothing but which is used to point out the item in the stack. That is the top of the element in the stack. So this is the stack example. In step 1, initially they are going to insert the value green into the stack. Initially the stack is empty, so the top value is equal to -1. If we are going to insert a new value, then the top is incremented by 1. So now the value of the top is equal to 1, and which is pointed to the new value green. Next, we are going to insert the next value which is known as blue. After inserting the value, before inserting the value, the top must be incremented by 1 to give the space. Then the value is inserted onto the stack. So blue. If we are going to delete the value blue, automatically the value is displayed over the screen. Then the top is decremented by 1. So again we are going to insert the value red. The top must be incremented by 1. The value is inserted into the stack. So now the value of the top is equal to red. Next we are going to delete the value red. So the top, after deleting that value, the top is decremented by 1. Next we are going to delete the value green. So automatically after deleting it, the top is decremented by 1. Now the value of the stack empty and the top value of the top is equal to -1. Next we are going to discuss about stack linked list implementation. So in this section, we present a linked list design for a stack. After developing this data structure, we write pseudocode algorithm for the stack ADT. So data structures and algorithm. This is the conceptual and physical stack implementation. So conceptually, we can see like this. Physically, how it is fully based upon the linked list. As we know that linked list means a list, a node consists of 2 elements which is known as data field and the next field. Data fields contains the value of the data and the next field contains the address of the next value. Initially the header node, sentinel node or dummy node must be there. Without the sentinel node, the entire list will be lost. So in the sentinel node, again it is also obviously it is also a node, so it contains two fields which is known as data field, and in the next field, in the data field, it contains the count of the number of nodes connected to it, and the top which contains the address of the first value in the list. So stack consists of two fields, count field and top field, and the node consists of two fields, data field and the link field. So initially there is no stack. If we wish to if we wish to create a stack, then the memory must be allocated for it. That is known as header node. So after creating the stack, the sentinel node will be created with the two fields, count is equal to 0 and top is equal to null. After inserting the value green, automatically the address of the value green is inserted into the sentinel node next field, that is the top field. Next, again we are going to insert the value blue. So if we are going to insert the value blue, then the values address of those things must be set properly over here. See, initially the only value which is connected to the header is green. Now here then we are going to insert the value blue as the first value. So we are going to give some modification over here by how is going to set the address of the green to the next value of blue, and the address of the blue is set to the header field. So likewise automatically the link will be sequentially set. Next, in order to pop the value, so need to remove the address of the value which is stored on the sentinel node and need to give the new address value of the next item, next node, then automatically it is set. At last, again, in order to destroy this stack, we need to destroy this stack because unnecessarily memory should not be allocated. So if we deallocate, we need to deallocate the memory, then it is efficient. So once our operations are over, then we need to deallocate the memory space which is allocated for the stack. This is the algorithm for creating stack. As I said before, we need to allocate the memory for stack head and set count is equal to 0 and top is equal to null initially. This is the algorithm for push stack. Allocate the new node and store data in new node. Make current top node the second node. Make new node the top. Increment the stack count. Push means inserting the new item. So before inserting the new item, the memory should be allocated for it. Then we need to store the value in the data field, and in the current field we need to set it as null. Address of this new node must be set in the sentinel node's next field, and we need to increment the top. And top in the sense count of the stack must be incremented by 1. Initially it is 0. After inserting the 1 value, it must be incremented by 1. Pop stack. If the stack is empty, the most important thing is we need to consider when we are going to insert a value or deleting a value, we need to check whether the overflow and underflow takes place or not. Overflow is nothing but if the stack is full, then the stack is overflow. If the stack is empty, then the underflow takes place. So before inserting the value into the stack, we need to check whether stack is full or not. If the stack is full, then we cannot able to allocate the memory for the new item. If the stack is empty, then it is impossible to delete an item. So before inserting or deleting, first check the overflow condition and underflow condition. So if the stack is empty, set success to false. Else, sells data out to data in top node, make second node the top node, decrement the stack count, set success to true. Stack top which is used to set the data out to data in top node and set success true. If the stack is empty, top is equal to -1. To empty this stack, automatically we can set the header node of a count field equal to 0 and next field as null. Automatically the stack will be empty. So these are the conditions to check whether it is overflow or underflow. If this memory is not available, then the stack is full. Which here stack count, which returns the number of elements currently in the stack. Obviously, I said after completing the operations of the stack, we must delete the memory space. So here destroy stack, which is used to release us all the nodes back to the dynamic memory. So initially, if the stack is not empty, then check it and delete the top node and delete the stack head. That's it.